Well, hello and welcome. It is time once again to try to fix something. Today on the workbench, I was able to find another dead PS5. They're so rare. And this one is actually rather dead. We do have power connected to it, by the way. Should be turning on. It is not. Okay, I think that's what it's supposed to be. I don't remember exactly on this one, but I'm pretty sure it was a no power. So let's get the covers off, shall we? That side plate is off, and obviously it is a 1215 model. You can tell by the small window sticker there. But yeah, I'm going to say she has been opened before. That decal, the security decal, does not look to be factory fresh. So yeah, that's not unusual. Let's get a little further into it, see if we have any signs of power inside. All right, we are getting down to the metal. And we can see if we have 12 volts right about in here. Nope, not there. Is it the other one? Yeah, that one. 11.98. So yeah, we have a working power supply. It does look like so. Yeah, quite possibly short on the motherboard. Let's see if we can find it. Well, here we are inside the workbench. Ready to take a look at this board, which is a EDM 031. Okay. I did a quick look over with it, just the naked eye, and I don't see any signs of previous work. So maybe it hasn't been worked on at all. I would like to see how much current it draws, though, from my bench supply. I've got it connected over there. You can see the polarity looks correct. Let's apply 12 volts to it and just see how much current we get. 160 milliamps, and we just kind of sit there. That does not look familiar. Okay. It's not normal and it's not familiar to me either. It does sound like some kind of a short, though, because it really shouldn't draw anything close to that. When you first turn on the power, it should draw like 8 or 10 milliamps, and then go up as it starts to actually do something. So yeah, let's look around with the meter maybe. Let's see what we can find. Let me get my meter set up here. Maybe continuity mode. Good place to start. Let me get that nulled out. All right. We don't have a 12 volt short because we would have, we would not have had 12 volts out there in the garage. 5 volt short? No 5 volt short. Okay. What about, again, around this IC right here? 3.3, I think, is right here. That's low. Okay. That's not normal. 38 ohms on the 3.3 volt rail. What about the 1.1, which is right here, I believe? 43 ohms there. Both of those are really low. Those both generated by the same IC here, which I can't tell. This is either, this is the Rich Tech RT5126, I think. I do have some of those. Very odd, though. I don't think I've ever seen one of those fail. I'm sure they can. Usually it's something that they, like the Southbridge, something that they feed power to is what shorts out, but that could still be the case. Could still be the case. What if we look underneath this Southbridge? Get a good ground. Check some of these. Yeah, there's 400 ohms. Some of these inductors going in. Nope. Nope. Just hitting some of these inductors that bring power in to that area of the Southbridge. Nothing shorted. What about, no, wouldn't be the Wi-Fi Bluetooth module. That has its own 3.3 volt supply. It doesn't use this one, the one that's over in this general area right here. Probably can see that short. What is that? Nope. This should be the back side of that area of that chip we were looking at earlier. No. I think these are bypass caps on the 5 volt rail going in on this side of the board. Okay. So, what are the odds that that chip is just bad? It could happen. Any other outputs? Reading low. 38, I think that's the same. I think it must be the 3.3 rail. It's a different capacitor I'm checking on. So these points must be connected. Let's see. Yeah, they are connected. Okay, so we're on the exact same point. So our 3.3 and our 1.15 both coming out of the same IC. Yeah, they're both not shorted, but they are low. I mean, they're low resistance. But this supply over here, this is like a, oh, that's, okay, that's ground, never mind. Every now and then you hit ground and you think you found something and you did not. You found ground. I don't think this is Southbridge. And I'm trying to think where else that 3.3 and that 1.15 would go to that would give us a reading like this. That's all fine there. Because I'm sure the fuse going in is fine. Yeah, that's the fuse going. It's what is that fuse? F7003. It's fine. Is it just the chip? Well, that'd be rather quick. I could just pop that chip off there and see if that low resistance goes away. Yeah, that's. What else could it be? Like I said, it's a separate supply for the Wi-Fi Bluetooth module. That's tapping ground. And is there anything in that area on the back? I don't believe that this is another DC-DC converter, the one for the SSD controller, but it gets 5 volts. It gets 5 volts directly to generate its voltage. It doesn't use the 3.3 or the 1.1. It makes its own. So I think we're at the point of just removing this RT5126, making a note of how low this resistance is. They're both around 40 ohms, 38, 39, and this over here is 43. Okay, they're both around 40 ohms, but that's two different outputs off that chip. What are the odds there? Let's get the hot air cranked up. Had my nozzle off. We'll get the hot air cranked up. Get the microscope cranked up. See if we can remove that chip. See what happens then. I still don't have my thermal camera, but I'm not sure if it would help us anyway, because we don't have a short. We have a low resistance. I wouldn't call that a short. It's just suspicious. Very suspicious. You can see it, RT5126. Let's give it some flux. Find my tweezers. I think I can go probably 440. It does have a rather large heatsink pad underneath it, so it will take some little bit of heat to get off. I have some of these new in a drawer that I'm hoping they're not fake. I'm not sure if I've actually tried one of them yet, so I'm really hoping that they are legit parts. There we go. All right, take that off. Let's see. We can just stay under the microscope if you'd like, just so you can see better where I was checking. Black probe on ground. I was checking like right here. 37 ohms. We still have 37 ohms. And right here, 41 ohms. So that was not our problem. That was not our problem. So where does the 3.3 and the 1.15 go other than the Southbridge? Let's see. Well, it would probably go to the HDMI area. But I think there's also 5 volts in that area. Let me just check around this a little. We are right behind the HDMI encoder, I see. See if I get that same reading. No, that's in the meg ohms. Yeah, that's in the K ohms. Anything around here with that low of a reading? Oh, 39 ohms. 39 ohms. So, the plot thickens. $39 ohms there. What is this right here? 320 ohms. I'm not sure what that is. That's a different feed. This right here. Let's look at the other side of the board in that same area. So here's your HDMI encoder I see right over here. For your reference. Do we have a short on this HDMI encoder? But we uses a 1.8 volt rail. That's 6.9 K ohms, and this is 300 ohms. It actually uses it uses 1.8. It uses a 0.9, and there may be some others. But we're in this little chip here. I know it takes in 5 volts. It outputs 0.9, but it takes in 5 volts. So I don't think that would be the issue. That's half a meg ohm. I'm trying to find that same low resistance on this side of the board. I don't think you'll find it there. I don't think I've had this exact problem before. I don't recall it. do not recall it. Go back over to the side of the board where we did see that problem. So this rail right here, that's a 1.8 volt regulator there. You can tell by that part number Y18. See what that voltage is, at least what I think it is. Yeah, that's a 1.8 volt rail. I believe it does take in 3.3 volts though. It does take in 3.3 on pin 1, I believe. This one right here. Yeah, that's 39 ohms. Okay, so this is one place it goes. You can see it goes to this. This is going to be a transistor here, a digital transistor, 1.8 volt regulator. But being it is the 3.3 volt rail, it probably goes to a lot of other places also. A lot of other places. Trying to think though. I did not find it looking under the Southbridge. I expected to find it in some of these. And one of these is 3.3 and one of them is 1.15, I think. But they're switched. They're switched by that RT5126. They're not there all the time. So I don't believe that's our issue. Because if it was bad, we would see it all the time right here under the Southbridge. And we don't. I sure don't. Interesting. Unless I'm just plain missing where it does come in as... No. And I need to figure out where that 1.15 goes. What uses that? Because it's also low. I think I do have one of these boards to compare to. EDM031. Just a moment. What is this? That's a 33. 32. Let's just compare the 32. Okay. I've got another board here at EDM032. Also with an RT5126 on it. It's not the dialog chip, it's the same chip, so same readings would apply. And I am getting 1.5 k ohms in climbing on the 1.15 rail, and on the 3.3, yeah, 2 k ohms in climbing. So, okay. So what do they have in common? What uses 3.3 and 1.15? I don't know. Well, this may not be as much of a mystery as I thought it was going to be. I think I have figured out that this is not all that different of a problem. I think we have a dead Southbridge. I didn't find that low resistance on any of these inductors, where it usually shows up on these larger inductors that surround the Southbridge. But measuring right in the middle under the Southbridge, there's that 43 ohms. So, and I think I found that 38 ohms right up on this corner. Yeah. So, something else I was going to show you over here. Here's where the supply comes from, the 3.3 and the 1.15. And if I check between those two, 7 ohms. 7 ohms shorted between those two. So yeah, I think our Southbridge has just failed in a new and exciting way. Normally I see it on a small capacitor over here on the south, underneath on this side of the RT5126 or whatever DC-DC controller happens to be here. Normally that's where I see the short. It shorts so often in the same way. It just decided to short a different way this time. So yeah, but it is just a regular old 61GG. Let's get it off there, and I bet our shorts go away, and I'll get that 5126 put back on there. Alright, I haven't done any cleanup of the solder balls under this chip yet, onto the Southbridge. I want to see right quick like if that low resistance has gone away now. I've not replaced the RT5126 yet. Let's just see what we get. Yeah, 2.6 meg ohms on the 3.3 volt rail, and the 1.1 or 1.15, whatever it is. If I can make contact on that capacitor there. Infinite? Oh, come on. Give me a reading. I don't believe it's that open. You know what? I wonder if it's possible that the only place that goes is to the Southbridge, and I've removed the Southbridge so it has no load whatsoever. And this side, the chip is gone, the RT5126. So this is just kind of floating there. Oh, there's 43. There's some capacitors there. So yeah, basically wide open though. With both these chips off, wide open. So yeah, okay, I'm convinced. And we need I believe the RT5126 is just fine. We just need a Southbridge, and I do believe I just got 4 of those in. Let me find them. That's a 42 GG. 62 GG. I know they're here. Okay, I'll find them. There they are. There they are. There they are. Yes. And there are 4. Well, 3. I guess I just replaced one, didn't I? And I have 3 good ones. This other one here is probably good. So, all right, that's all I need. Need to order some more of those, I guess. Seem to go through those a lot. Alright then, our Southbridge has been changed. I reinstalled the RT5126 right over here. So have we done any good? Let's just see. Alright, I've got my leads connected properly. What kind of current draw do we get now? There we go, 320, come back down. That looks normal. Perfectly normal. Alright, so just a bad Southbridge. Okay, nothing major. Alright, we'll get this back out in the garage and we will hook this into the, put it back in the chassis and let's just see if it'll turn on now. I bet it does. Well, here we are back out in the garage, ready to test this board and see if we've done any good with it whatsoever. Power, video, fan, lights, the ribbon cable for the buttons. What happens? Okay. That looks like progress. Oh, the monitor locked. There we go. Excellent. She's going to come on up. All right. All right, let me get this fully put back together and give it a little more testing. All right, well, this PS5 is fully reassembled and seems to be working just fine. I'm going to grab a Blu-ray disc, a PS5 game, and install that just to give it a good thorough check out. But so far, so good. I hope you liked that one. Thought it was somewhat interesting, educational, entertaining, any of the above. If you did, please give me a thumbs up. And I'll see you in that very next repair. Bye for now.